All right, today we're going to go on a bit of a journey, an investigator's journey. But our mystery, it isn't some crime scene. No, it's the unknown itself. We're going to break down this whole systematic process of discovery that we call research and really get to the bottom of how we come to know things. I mean, seriously, think about it for a second. How do we know for sure that a new medicine actually works? Or that one algorithm is genuinely faster than another? The answer isn't just about Googling facts. It's about going on a structured, systematic quest for the truth. So let's start by defining what that quest even is.
So yeah, our investigation kicks off at square one. What is this thing we call research? Because, it's so much more than a simple search. It's literally the foundation for how we build all new knowledge.
The key word right here is systematized. Research isn't just stumbling around in the dark hoping you find something. It's a deliberate, structured method for either cracking a specific problem or adding one more essential piece to the giant, ongoing puzzle of human understanding.
And what drives this whole effort? Well, it's something deeply human. It could be that intellectual rush you get from solving a tough puzzle, or maybe a desire to help society. Or sometimes it's just pure, simple curiosity. Whatever that initial spark is, that's the real engine of discovery.
So once an investigator has their motivation, their why, they need to choose a path. And just like any great adventure, not all paths are the same. There are different kinds of investigations, and each one has its own unique purpose.
Okay, pop quiz time. A little riddle for you. I'm chasing theories and laws, not building a product. What am I? Think about it. This type of research isn't about some immediate practical result. It's all about understanding for the sake of understanding. Any ideas?
If you were thinking basic research, you absolutely nailed it. This is the fundamental curiosity-driven science that expands our entire knowledge base. Think of physicists digging into quantum theory, or a computer scientist wrestling with that infamous P versus NP problem. They're not building a product for next week, they're laying the foundation for the game-changing innovations of the next century.
All right, you ready for round two? I don't just wonder, I solve and I do. Who am I? See, this investigator's quest is totally different. It's grounded, it's practical, and it's focused on a problem that needs solving right now. It takes knowledge that's already out there and puts it to work. Any guesses this time?
This is applied research, and its goal is a direct, real-world solution. This is how we get AI systems that can spot diseases in medical scans, or algorithms that detect cyberbullying online. It takes that pure knowledge we just talked about and applies it to make a real difference right now. And here's the beautiful part. Applied research often digs up new questions, which then inspires more basic research. It's this amazing, constant cycle of discovery and innovation.
Now, regardless of the quest, every investigator needs the right lens to look at their clues. So think of it this way. Quantitative research is all about the what and how many. It uses numbers to measure and predict. Qualitative research is about the why. It explores meaning and context through things like interviews or images. And as you can probably guess, mixed methods just combines both to get the most complete picture of the mystery.
So, you've got your motivation, you've picked your quest type, and you've chosen your lens. What you need now is a map, a reliable, time-tested guide that makes sure your journey actually leads to a real discovery. And for investigators of the unknown, that map is the scientific method.
This map lays out a super clear path. It all kicks off with a simple observation, just noticing a mystery. From there, you pin down the core question, and then you study past cases to see what other investigators have already found. Then comes the fun part. You form a hunch, your hypothesis, gather your clues, and connect the dots. Finally, you draw your conclusion. You solve the case. It's a logical, repeatable process that anyone can follow.
Let's zoom in on that hunch, the hypothesis, because this is really important. A huge part of this process is that you have to start with a skeptical mindset. You begin with what's called the null hypothesis. That's the default assumption that there's no effect, nothing's happening. So for example, your gut might tell you a new algorithm is faster, but your null hypothesis has to be that it has no effect on speed. Your real claim, the alternative hypothesis, is what you're actually trying to prove with all your evidence, that the algorithm really is significantly faster.
But, reading the clues can be tricky. There are two major pitfalls you can fall into. A type 1 error is basically a false alarm. Think of a smoke detector going off when there's no fire. You conclude your discovery is real, but it actually isn't. Then there's a type 2 error, which is a misdiscovery. This time, there is a fire, but the smoke detector just fails to go off. Your discovery is real, but your evidence wasn't strong enough to see it. An investigator's goal is to navigate these traps and find what's really true.
A good investigator never just rushes in. They plan, because a really solid plan is the difference between a successful investigation and, well, a wild goose chase.
And here's what that journey's itinerary often looks like. As you can see, this is not a weekend trip. It's a methodical expedition that unfolds over months, with very clear phases for figuring out the problem, gathering clues, analyzing what you found, and finally, writing it all down. Each step builds on the one before it. And hey, before any big journey, you gotta pack the right gear. First up, your scope. Think of this as the map itself, defining the exact boundaries of your investigation. Next, your limitations. This is you being honest about the tough terrain ahead, like a tight budget or limited time. And finally, your timeline. That's the itinerary that keeps the entire expedition on track.
Okay, we've hit the final leg of the journey, because a discovery that you keep to yourself is a discovery that's wasted. The single most important step is bringing that knowledge back and sharing it with the world.
This is the ultimate goal. The final report, the published paper, the presentation at a conference, this becomes the official case file of your investigation. It documents your entire journey, your methods, your evidence, and your final conclusion. This lets other investigators learn from your work, check it, and most importantly, build on top of it. This is how one single discovery gets transformed into our collective human knowledge.
So, there you have it, the investigator's journey. From that first little spark of curiosity all the way to sharing your findings with the world, you now hold the map. And look, this process isn't just for scientists in white lab coats. It is a powerful tool for anyone who has a question. The only thing left to ask is, what mystery are you going to solve first?